when? So 19,
1812.
where's the year? Top right? This one? Can you read it?
Bottom you have war of 1812.
It's 1812. Okay? So it's Napoleon marched to the Moscow, right? At the time, this has been drawn by the not mathematician, some of the scholar wrote it. This width represent number of soldiers. Okay, this is the time. Okay, then there are certain event. Also, this means the split. The branch means one group actually march to different way and something like that. So also it shows. I'm not sure whether you can realize the details of it. It has temperature. You probably know that Napoleon's march to the Moscow actually is very cold time, and also sometimes it has a geographical information like this one. They cross the river, where after the river they stop, which means so. I think something happened. Okay, then finally arrived here, and this one is kind of the data visualization. All the data visualization, it can represent at least 7 or 8 attributes at the same time. Okay, so this is kind of the idea of the data visualization. So I got I noticed this figure first time from the advertisement. Somebody said the very big the bromide, it's a $30, $40. So at that time, I realized the Napoleon is much. This is a very popular, famous figure to shows how much powerful the data visualization is. So, and there are available the data visualization tool. This is the couple of years ago, but still some of them are available. So for example, Excel is still one of them. I said really. So Excel is very powerful. So still many of the company use Excel itself to analyze the data. Also, there are existing tool that is based on the Excel. Why? Because many of the company they do not have the database system. Okay, they just keep the customer information in the Excel, or like me, I manage my student information in the Excel file. So using Excel, there are existing the program actually to analyze such Excel data. Okay? Google Chart and Google API is very powerful. Why don't you try? It's very, very useful. And also nowadays, if you have the big data system, you can use the Google, I forgot the name of that. There is which is the Google, the big NoSQL database. So you can use such a NoSQL database with the visualization tool. So also this is another one, so you can check it. Not all of them are currently available, but mostly available. The last, before we finalize today's lecture, that this is one of the important part, how to measure. So far we have talked about the data itself and how to define the data. What time is it? 16? So 10 more minutes, 5 more minutes. Okay? So there are two ways to compare the data item. One is similarity, another one is how much it is similar. What about the Euclidean distance? Is it similarity based or dissimilarity based? It's a dissimilarity. If two items are identical, which means the same number, Euclidean distance is 0, which means it's the same means 0, which means it's based on the dissimilarity. However, not always you can use the dissimilarity to compare the data item. Sometimes it's, for example, image. How much is similar? That's natural. Okay. which means if they are identical image, which means it's a similar. So similar means the infinite number. Okay? If that they are same, it's an infinite number. So similar, it shows a similarity. So not always a dissimilarity, which is popular, but the similarity based approach mostly the numeric based data measurement is a dissimilarity. Non-numeric data or the sum of the non-structured data is based on the similarity. At that time, it's a better idea you can normalize such a distance, the similarity, like for example 0 to 1, okay? Or sometimes if you cannot clarify whether this is a similarity or dissimilarity, that is also possible. We can say the approximate to represent either similarity or dissimilarity. So in case of the matrix, okay, we can compute the similarity. So in case we have the n data point, then we can compute the distance for each item. Okay? Then this one is a symmetric, so we don't have to represent both the 1 and 2 items, something like that. You can use the matrix, or sometimes for the nominal. What is the nominal data?
Category.
It's just category, like the white, black, or blonde hair. Then how can we compare such the nominal data? How much similar, how much dissimilar? That is the idea. How many of them are matched among the total number? Something like that. Is it the general? It depends on your data. This is not always true. This depends on your data. That's another important thing. After you define your data set, how to compare? That is another issue. Very, very difficult sometimes. So also it can be good news or bad news. The good news and the bad news is not easy, not obvious to find such the similarity or dissimilarity. The good news is you can propose your own. Okay? That will be the first one. So in my dissertation, I proposed extended something existing. I used the edit distance. Edit distance is the similarity measure between two strings. Okay? If two strings are same, it's a dissimilarity. It's a 0. If they are totally different, it's a forever. So like that. So I extend that edit distance for the video data set. Something like that. So you can define your own. But this is one of the examples. In case of the binary attribute, and so as I said, the binary attribute, how to compare the binary. Okay, so at that time we can use the Jacob coefficient, which is popular. It's a similarity measure. Okay? I think intuitively you can understand. For example, the object 1, object 2, and it has 1, 0, 1, 0. How many of them are the 1 and 1? How many of them are 1 and 0? And these are the number. Q, R, S, T are the number. And using, so for example, if you use the symmetric, the binary variable, you can total number of the R plus S, which means it's 0, 1. Whether only count the different thing. How many items are different? How many items are different? That is R plus S over total number. Something like that. Okay? And also this is another way to measure the dissimilarity of the binary data. Okay? So Jack, the man, the gender is the man or the male or female, and the female yes or no, and all of them are binary. That's true. That is possible. And whether Jack is similar to Mary or Jack is similar to Sim, if we can find the similar one, actually from the history, we can consider the previous treatment. That's the idea. So from the patient information, so if you have something test result or something the other medication, if you can find similar using such an approach, then how many of them are matched. Or even you can give your own weight. For example, the fever is important factor. So you not in this case is the same weight, but you can give the 50% of the weight. Okay? So when you consider such the similarity or dissimilarity, do not use as it is. Okay? It depends on your data set. Also, it depends on your problem. And also, we can use the standardized numeric data, which means we can make the normalize such a data. Okay? So this square is, you can see, we can take out the mean value and divide by variance. That means we can adjust to the normal distribution. Then find the p-value and count it. This is from the matrix. So we already seen the similar one from the matrix. So for each element, we can calculate the distance, Euclidean distance for each element. So Minkowski distance is the kind of the general distance measure. Okay, it's a very popular. Still, we are using a lot. So, but as you can see, the Minkowski distance is for each element. We can power h. It can be from 1 to many. Then square root of h. So, in case of the 2, that is the Euclidean distance, square and square root for each item. And in case of 1, it's called the city block distance or Manhattan distance. The reason why it's called the Manhattan or city block distance is it's not like the distance between this, like this. We can consider as the grid. So distance from here to here is 1, 2, 3, 4, 5. Just like when you travel in Manhattan, you cannot close in the building side. You need to go to edges like that. That is the reason it's called the Manhattan distance in case h is equal to 1. Okay? And it can be, the h can be go to the infinite, depending on your data set. Okay? Always is such a, so when you test, when you implement, for example, the clustering algorithm, which will be the second project, so you can test actually the different h value, then you will see the difference result. Okay? So that is the Minkowski distance. One of the reasons why we prefer such a Minkowski distance is a metric space. What is a metric? Metric is comparable. So if, as you can see here, is a triangular inequality. So if distance A, B, so if the distance from this one and this is, if the distance between A and B, then if you have the C point, AC plus BC, is it equal or less than, bigger or less, equal or bigger than AB, right? This is obvious only in metric space. So because of this, we can actually line up, make the order, then we can consider the rank. Okay, that is a triangular inequality. Then that is the reason we can use because the Minkowski distance is a metric space, metric, so we can index such a metric space data. Index is order, kind of, right? So we can pick up the top of them. Many of the similarity-based approach is not metric, which means it cannot be indexed. We will see such a example. So actually that is the main part of my dissertation in my PhD. I try to make the non-metric distance measure to the metric space. Then, which means it can be indexed. We will see the cosine similarity a little bit. the next week, okay, then we will move to the chapter 3. So that is the first part of the data mining technique.